Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signals and Systems Analysis. In this video, I will show you the solution to finding an impulse response of a given linear differential system, which is question number 1. Okay, so you are given this linear differential equation, okay, and you are asked to determine the h of t, which is the impulse response of the system. And so in order to solve this problem, the first step to do is to write the differential equation in terms of d, where we know that d equals to d over dt, capital D equals to d over dt. So this one means d plus, since we have to the power of 2, so this is d square plus 5d plus 6 y of t equals to d plus 1 x of t. Okay, where we know that this part here is qd and this part here is p of d. Okay, so which brings us to the second step, where we have to determine BO and PD. So BO is the multiplier to the highest derivative of the input. So here the highest derivative is d to the power of 1, where the multiplier here is 1. However, in the slide, okay, where I discuss impulse response, okay, you can either watch the video or refer to the slide. We also say that when m is smaller than n, okay, where this m here is the number of derivative of the input, and this mn here is the highest number of derivative of the output, which is y of t. So in this case, m is 1, okay, because this d is to the power of 1, while n here is 2, because d here is to the power of 2. So in this case, we have m smaller than n. So in the case that m smaller than n, we will have BO equals to 0. Okay, and PD given by this polynomial over here. Okay, so PD is d plus 1. The next step is to determine yn of t, okay, which can be done by following these two steps. Okay, first you have to find the roots of the characteristic equation, which is q lambda equals to 0. Okay, which we obtain by simply substituting d, okay, qd with lambda. And then second step is to find either c1, c2 or c and theta, depending on the types of roots that we get. So we have our characteristic equation, okay, lambda square plus 5 lambda plus 6 equals to 0, okay, which is from this here, okay, simply substitute this d with lambda. So here we have lambda plus 3 and lambda plus 2, 0, okay, so we have lambda 1 equals to minus 3 and lambda 2 equals to minus 2. So if we write this into the general solution, okay, of yn of t, it will be c1e alpha 1 lambda 1t plus c2e lambda 2t, which is, if we substitute lambda, c1e minus 3t plus c2e minus 2t. Okay, so the next step is we want to determine c1 and c2. Okay, so you can do this by using initial conditions. So in the slides where I discuss impulse response, I mentioned that if we have n equals to 2, we have initial condition of yn0 equals to 0 and yn dot 0 equals to 1. Okay, so we can use these two initial conditions to determine C. Okay, so for yn of 0, which is 0, we have C1e to the power of 0 plus C2e to the power of 0. Okay, minus 3 multiplied by 0 minus 2 multiplied by 0. So we will have E equals to C1 plus, 0 equals to C1 plus C2. Okay, or simply C1 equals to minus C2. Now yn dot of 0, which is equals to 1. Okay, so you simply differentiate this. Okay, so you will get minus 3 C1 E minus 3T plus C2E. Sorry, this one is minus 2 C2E minus 2T. Okay, so 1 equals to, just substitute all the T here with 0, so you will have minus 3 C1 minus 2 C2. So if you substitute this C2 with minus C1, you will get, or rather C1, this C1 equals to minus C2, you will get C2 equals to 1. Okay, which means your C1 is minus 1. Okay, so your yn of t, substituting C1 and C2, will be minus E minus 3T plus E minus 2T. Okay, this is yn of t. Now the next step is to determine h of t using this formula over here. Okay, so our BO is 0. Okay, since we have m smaller than n, so this part will be 0. So you're left with h of t equals to P of d. We already find, okay, in the second step here, PD equals to d plus 1. So here we have d plus 1, yn of t, u of t. So here if I multiply, I will get d yn of t plus yn of t ut. Okay, so this part over here, okay, simply means the first derivative of yn of t. Okay, because we have d equals to capital D equals to d over dt. So this one can be rewritten as yn dot of t plus yn of t ut. This one is from here. Okay, from here you simply substitute this c with 1 and this c2 with minus 1. So you will get 3e minus 3t minus 2e minus 2t minus e minus 3t plus e minus 2t u of t. So there's here and here, you can perform some operations. Here you will leave with 2e minus 3t minus e minus 2t u of t. So this is the impulse response of the given system. I'll see you in the next video for the solution to question number 2. Thank you.